I sometimes like to think of myself as a bit of an iconoclast. I don't really mind and sometimes even like holding different views to the mainstream. Saying that an idea is popular is not the best way to win me over in an argument. It takes more than that. However, I recently found out that I am now a member of the biggest community of programmers on the planet. One of my languages of choice is Python, and Python recently became the most popular language of all. So what is it that makes Python quite so popular? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. I've programmed professionally in somewhere in the region of about 20 different programming languages over the years. But these days, if I have a personal project, Python is the most often my go-to default language. I confess that it's probably not the language that I would choose to build something as part of a bigger team, or for something where performance was important. More on both of those things a bit later. But for smaller individual projects, Python is usually what I reach for. I'm not alone in that. Python has the advantage of being quite a low overhead language as languages go, which makes it much easier for beginners to learn and easy to migrate to for people like me who already know some other programming languages. If you aren't familiar with it, Python is a general purpose, high level, object-oriented interpreted language. But it's also very low overhead and is perfectly able to work as a functional, procedural or non-OO modular language. You can write simple code in a few lines with no obvious structure if you really must, or build whole complex systems with some pretty simple structural basics. One of the other big advantages is that it runs nearly everywhere. It's even sometimes used for embedded systems, though Python isn't the most popular or natural choice for those kinds of systems just yet. Python's also open source and so completely free, even for commercial systems. And so it's also now the most popular language for teaching programming as well as for general use. At least it's the most popular language for teaching in American universities. This is important in helping Python spread in terms of popularity because it means that new graduates come straight out of university knowing some Python already, and so it'll be a bit less of an effort and less to learn if they're joining a Python project. Let me pause there and say thank you to our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Tricentis and Transfic. All of these companies offer products and services that are well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, click on the links in the description below and check them out. Python began life in the late 1980s and was written by Guido van Rossum, whose continued involvement and leadership has earned him the title from the Python community of Benevolent Dictator for Life. I think that this consistency of vision has probably helped Python too. Python is a clean, no-fuss language that has successfully avoided some of the failures of design by committee that are so often prevalent in languages like Java and, most notably from my point of view, C++, which I think became a casualty of standardization committees. For an OO language, Python was also a relatively early adopter of functional constructs, adding lambdas, MapReduce and filters in January of 1994. I think that one of the more technical advantages that Python has is that it is very versatile. Technically, that's true of any general purpose language. By definition, a general purpose programming language can solve any problem that you can solve in any other general purpose language. But in common with other very popular languages, Python has, over the years, grown a significant amount of support in the form of tools, frameworks, libraries, and extensions. You can do anything from write a web page to train an AI system in Python, from building embedded systems to scripting trading algorithms or writing games in Python. And you will find libraries, tutorials, and tools and communities to help you. I've been having some fun recently building some simple video games using test-driven development and Python. And as I had a choice of libraries to help me with some of the lower level aspects of game writing, this availability of libraries and frameworks is a consequence of there being a huge and diverse community of Python programmers that companies can recruit and that we can call upon to get answers when we're stuck. I've just released a new how-to guide on the habits of great programmers. You can find a link to download this free guide in the description to this video underneath. I think that the communities around Python have long been another of its very big strengths. My impression, and it is only that, is that the vibe is more relaxed and less about programming religion of some kind than some language groups that I could point to. Python is more about just getting stuff done than it is about programming zealotry. At least that's my impression. Python is a practical tool, and I think largely that is the way that it's seen. Python has some strong guidance for good programming too, in the form of some coding standards, or more accurately, a style guide called PEP. The current version is PEP 8. I confess that I have a bit of an ambivalent relationship with PEP and PEP 8. It's not really that there's anything that I disagree with very strongly in it, but as PEP 8 itself says, foolish consistency is the hobgobbling of small minds. I have experienced the most zealotry in Python around adherence or not to PEP 8, which I guess colours my opinion. In particular, I'm not a big fan of comments in code. Sometimes they're useful, more often, quite often, they're not. If I write a function with some arguments, then I need to document what the function does and what the arguments mean. I've probably done a poor job of the function and naming the arguments. But my IDE nags me about not adhering to PEP 8. I know I could turn it off, but I don't get around to it. And in the past, colleagues have made similar comments about my code, even though they agreed with me that they could tell what the code was doing and what the parameters meant. My main PEP 8 heresy, though, is that I spent enough time programming in languages like Java and C# to prefer camel case for names over lowercase and underscores, which is the default for most Python constructs. As a result, sometimes I forget in my Python and revert to camel case, so shoot me. In general though, I'm a big fan of adopting a consistent set of conventions and usually value consistency very highly in my own code and within a team. I care less about necessarily having all of the Python code in the world being stylistically consistent, but I do value that PEP sets out the guidelines, so we don't need to think too hard about our own version unless we really want to. As an aside, whatever your language, I think it's good to add style or coding standard checks as part of your commit stage testing, and those tests should reject commits that don't abide by the team's agreed coding standards. PEP 8 makes this easy to implement. I've said before that these days Python is my go-to language for small, simple solo projects. I also often use it to demonstrate programming ideas here and in my training courses because it's such a simple language that I assume most programmers will be able to read it and understand it, even if they don't know Python very well. There's simply less distracting boilerplate than there is in most other languages. But I wouldn't normally choose Python for team-based commercial development myself. That's clearly not because Python can't do those kinds of projects, but at least for the kind of software that I used to write as part of teams, it's extra work to add some of the things that I think helps with team development. I used to work on very high performance systems, and Python is not a good choice for those kinds of things. Python's slow. Partly this is because it's an interpreted language, and partly I think that it hasn't had the kind of investment in compilation technology that some other languages have had. Python is very slow. 40 to 50 times slower on average than most of the popular higher performance languages like C++, Java or C#. But in reality, the usual argument, and it's correct, is that practically this doesn't matter at all for most systems, as Python is more than fast enough to get the job done. Except for systems where raw performance is a prerequisite, I suppose. This is true, But slower code also means less energy efficient code, and data centers in the cloud are significant contributors to our CO2 problem. So faster code results in lower CO2 emissions and bigger bills for your cloud usage or your data center because you'll need more compute. So that may be worth thinking about for bigger systems. That aside though, you can certainly write code that will get the job done in Python for most flavors of getting the job done. Now though, there are some alternatives that address even this part of the performance problem. There's a new Python compatible language called Mojo that makes some very extravagant performance claims. It claims 39,000 times faster than Python alone in some use cases. After a fair bit of rework, I think it's fair to say. The other property of Python that has in the past stopped it being my default choice for bigger projects though, has been its dynamic type system. But now we can solve this problem too. I think that static typing is a powerful tool for communicating design intent for teams. Being able to clearly define and express the defensible contract that one piece of code has with another provides a lot of advantages. Not least, it means that my IDE can be smarter. My IDE can catch mistakes that in Python I'll only discover at runtime. This rules out all sorts of insidious bugs that are actually fairly common in Python projects. If I can find bugs as I am typing rather than waiting until runtime, I'm of course going to prefer that. This comes at the cost of a small amount of additional typing, if you'll forgive the pun. But for me at least, a few characters extra is a small price to pay. As I said though, this has been fixed now in newer versions of Python, where I can be explicit now about the types and get instant type checking rather like this. I'm not sure if this would be enough for me to choose Python over say Java or C# for development. To be honest, it would depend on the team and what they thought. But if it was my choice, I'd be okay with going with Python now, if I could enforce the use of static types. Maybe with a commit test perhaps. I like Python as a practical, sensible workhorse language. And while I don't really know why, for some reason, I do feel quite pleased that this practical, no-nonsense tool has become the world's most popular programming language. Thank you very much for watching today. If you have been watching and you enjoy the content on this channel, please do consider supporting our work by joining our Patreon community. There are lots of benefits to that, but we'll be very grateful for your support, and we are fantastically grateful for our existing Patreon members. Thank you again.